concepts, and they're really quite simple. You have words, the words that you're familiar with, that are coming out of my mouth in speech form, and that you can write here on a web page in script form. And you know, in human language, words are ambiguous. The same word can mean different things. And how is that not a problem? Well, sometimes it's a problem and sometimes it's hilarious. But most of the time, our brains are perfectly capable of handling it, because words mean something in contexts. And the human brain is very good at switching contexts. If you walk through that door, your brain immediately knows that you're entering a new context. And it's also layered, it's stacked. Your brain knows you're in Amsterdam. Your brain knows you're at the CBE in this building. Your brain knows you're in this room, the ADA room. If you walk through that door, the top of that stack changes. And you know, now I'm leaving this room and I'm going to the hallway, maybe to the stairs or the exit door. And then the focused context, it's a sort of focus stack in your brain. And it's a layered stack of contexts that your brain is always aware it is in. The brain's extremely good at it, and because it's mostly linked to a spatial sensation, but we've also become very good at it in the past thousands of years when it's in writing. And then the last 100 years, because of Lady Ada, we can also put this upon computers, because computers in the current von Neumann architecture don't know nothing about this. This is a brain thing. This is human brain function. And this model has to be put onto the stupid chips in our stupid computers. So many computer languages, and this starts with assembly or toggling switches on a dashboard 60 years ago, computers have to be taught more to think like humans. And this is how humans think. This is how their brain works. And this is a lot how Rebel works. And when you say that Rebel enables new inventions, new programs, and thereby new programmatic inventions, it is because Rebel does an extremely good job at bridging the huge gap between current hardware in computers and how human brains think. And human brains are very hard to change. And computer hardware is easier to change, but it's also quite hard to change. The easiest thing to bridge the gap is changing the software. And that comes down to the written language that we now work with for the last several thousand years. So this is the conceptual model in Boron and Rebel. You'll have words, and words are symbols, and words can mean something, and Rebel calls that values. A word can have a value, and then it starts to look more like a traditional computer language, and then you get an idea what the value might mean. But what a symbol means, what value it has, depends on the context. And in computer language terms, that means that you have to bind the symbol to the context. So you have a symbol, it doesn't mean anything but the symbol itself. To know what the symbol means, what value it has, you have to tell in what context you want to interpret it. And that you do in computer language terms by binding. The brain does that automatically all the time. It's continuously binding symbols to contexts. And Rebel tries to do that too as well as it can. And in any case, it does it a lot better than other languages. So, similar to human language. So these are the very elementary concepts. And you can recognize them in other high-level computer languages, but the focus is different. If you talk in other computer languages, they talk about these things, but they talk a lot more about other things. The bias is different. This is really very fundamental to Boron. So this is a very short overview of types, and belonging to this is a rich type system. And it's richer in Rebel. Rebel has more data types than Boron. That's something that's easy to add, so that can develop over time. But in general, there are more data types than in other languages. For example, Rebel has data types for email and for URL. And that's not very human brain-like, but it is very internet computer-like. So it's somewhere between the brain and the computer. So that's one way of bridging the gap. Boron doesn't have types for email and URL yet, but of course you can code that in strings. But if you make it a special data type, the language knows better what it means. A string is much more general than an email address. If you can say this type is really an email address, that means a lot more than it is a string and it may be an email address. So one of the things supporting this is a rich type system. But it's basically fairly straightforward. Strings are very well known, of course. There are two kinds of delimiters, so it's very comfortable to have new lines, line breaks in your text. And with this form, you can nest them because the start and end tag are different. A symbol is something that doesn't get much attention in other languages, but is very fundamental to Boron. And if you want a literal, then you have to encode it this way in the literal encoding in a program text. And that means that it won't be bound automatically. If you don't do that, it will usually be bound automatically to the global context. So if you do it this way, you're free not to bind it, so you can simply use it as a symbol. What other languages call a keyword or an enumeration type. And you can also choose to bind it at a later time at your convenience. So you have complete control over the binding process. So the weird thing about Boron and Rebel is that it's a very high level language, because I was looking for the highest level language that was still general purpose that I could find to do more things more efficiently on my own if I had to. At the same time, because Rebel gives you very low level access to language features, it's also a sort of Forth-like, assembler-like language that you can really bend to what you want to do. So you can construct your own contexts and bind symbols to it when and where you want. And another thing supporting this is the notion of series, a series that is a sequence of multiple values. Maybe the same value, so a string is built up out of characters. You find that notion in many programming languages, but Boron takes it a lot further. And, one thing is blocks. Blocks is very Lisp-like. It's like a Lisp S expression or something. A block is a list of other values. So you can also use it for nesting. So you can build arbitrarily complex data structures with nested blocks. And there's a variation of it, parents, which is mostly used for giving precedence to an expression, but blocks are most used. And there are a few varieties, because this is the conceptual idea, just a list, a block. But you can say that you want a hash, or in Rebel 2 you can say that you want it to be a linked list. That was dumped in Rebel 3 because it wasn't really used. And you can have, in Rebel 3 you can now have vectors, and in Boron 2, which are very efficient arrays. All the languages call them arrays. But their notation, their literal notation is the same. So you can write your program this way, as if you're using blocks, And depending on the performance you want, you can change the type underneath, under the hood, to a hash or a vector. And you can have an enormous difference in performance when you need it, but in many cases without changing the code. So that's a way of bridging to the machine level, to the current von Neumann architecture computers. Well, this is an example, and here is a new link, and it is supposed to run in CGI mode this Boron example, and just an hour ago I had it working and then it stopped working, so this is probably not going to work. Oh, it works, okay. Probably if I select the next example it won't work. So what it has done now, we were in slide 3.html, pre-generated static page really, generated by Boron, but we'll see that. But this is dynamically generated. This is the Boron program taking this example out of this slide, making a loose Linux script out of it, and then if you click this link, it will be executed and you get the output in a new web page, which is extremely simple. This is just the text output in the source view, while this is a real HTML